All right, let's talk about databases. For decades, the world ran on these neat, tidy tables with rows and columns. But what happens when your data is messy, when it doesn't fit in a perfect little box? That's exactly where we're going today, diving deep into the architecture of MongoDB, a database that was literally built for the way modern applications actually work.
So check this out. This slide just perfectly nails the problem. On the left, that's the old school relational world. To understand a single customer order, you have to piece it together from, what, 4, 5 different tables? It's complicated. Now look at the right. That's the document model. Everything, the user, the products, the address, it's all together in one logical document. It's exactly how you, as a developer, would think about it in your code. This right here, this solves that classic impedance mismatch.
And this is the magic behind it, a document database. Instead of rows and columns, it stores data in these flexible, JSON-like documents. You can just think of a document as a complete, self-contained package of information about one thing. A user document has all the user info. A product document has all the product info. It's just a much more natural way to model the real world.
Okay, so if you're coming from a SQL background, you might be thinking, this is a whole new world. But honestly, it's not as different as you think. You really just need to learn a little bit of new vocabulary, because the core ideas are pretty much the same.
This right here is your Rosetta Stone. Seriously, what you used to call a table? Well, in Mongo, that's a collection. A row becomes a document. A column? That's just a field. And those complex joins that could give you a headache, you now either embed data directly or use a cool operator called @lookup. See? It's basically a direct translation.
And here, this is the real game changer, the idea of a flexible schema. Unlike a rigid SQL table, where every single row must have the same columns, a MongoDB collection is way more chill. One document in your products collection might have a size field, but another one could have a megapixels field. It means your database can evolve as your application evolves without all those painful weekend-long migrations.
This brings us to probably the single most important strategic decision you have to make when you're designing your app with MongoDB. How are you going to structure the relationships between your data?
And the answer starts with this golden rule. Just burn this into your brain. Data that is accessed together should be stored together. It is the #1 principle for building fast, efficient models in MongoDB. So if your app's user profile page always shows their 5 most recent comments, well, this rule is telling you to maybe store those comments right inside the user document.
So you've got 2 main tools to make that happen. On the left, you've got embedding. That's where you literally nest related info, like an address, directly inside the user document. It makes reading data incredibly fast. On the right, you have referencing. This is more like what you're used to with SQL, where you store things in different collections, say blog posts and comments, and link them with an ID. So how do you choose? Well, it almost always comes down to something called cardinality. It's a fancy word, but it just means what's the relationship. If it's a one-to-one thing, like a user and their profile, embed it. One to a few, like a user with 2 or 3 addresses, yeah, embed that too. But once you get to one-to-many, like a product with thousands of reviews, or what we like to call one-to-zillions, you absolutely have to reference it. Otherwise, your documents will get way too big.
All right, that's enough theory for a bit. Let's get practical. How do you actually work with the data? Let's walk through the basic operations that are the bread and butter of any application. We're talking about CRUD. You know it, you love it. Create, read, update, and delete. These 4 actions are the absolute foundation of everything. And in MongoDB, the way you perform them is designed to be super clean and really intuitive.
So, creating a new record, you just use insert 1. And just look at how clean that is. You're not messing with long SQL strings. You're just handing the database a simple JavaScript-like object. What you see is what you get. Reading data is just as easy. You use find, and you pass it a query document that acts like a filter. Here, for example, we're using that little $GT operator, which just means greater than, to find everybody who is older than 30. Simple as that.
Okay, what about updating? You use a command like update1. It takes 2 main things. First, a filter to find the exact document you want to change, and second, an update document that uses an operator like $set to tell Mongo exactly which field to change and what to change it to. And finally, deleting a document? It's the same simple pattern. You find the document you want to get rid of with a filter, and then you just call delete1, boom, it's gone. These 4 CRUD operations really are the core of everything, and they just feel natural in Mongo.
So, basic queries are great, for sure, but what if you need to do some real analysis?
What's the MongoDB version of a big SQL query with a group by and a sum? Well, for that, you turn to the super powerful aggregation framework.
The best way to picture this is like a data assembly line. Your raw documents go in one end, and they move through a series of stages. Each stage does one specific thing: filters, groups, sorts, you name it, and then a totally transformed result comes out the other side.
And this is a super common pipeline you'd build. First, use a $match stage to grab only the documents you actually care about. Then, you can pipe those into a $group stage to do calculations, like get the average sales per region. And finally, you might use a $sort stage to order the results. You can chain these stages together to do some incredibly complex analytics, all inside the database itself.
At the end of the day, here's the big takeaway. MongoDB's document model isn't just some random feature. It's a whole philosophy. It's about designing a database that actually works the way your application and your developers think. And that really leaves you with one final, critical question to ask on any project. Your application's data is flexible, it's messy, it's always changing. Is your database?